Good morning. Yours truly, Professor Dr. Dolphy Gilpin, as I return to the Holiday Inn Express at Heatrow, London Airport. And I'm here on the description of elements of the periodic table, and they are random selected, and we're just given 3 intrinsic statistics of these elements, whichever comes up in our choices. Just atomic weight, the atomic number, and the electrons configuration, and sometimes other brief notes. Like for francium, we'd say this is one of the most radioactive synthetic elements. Radium and radon are very radioactive as well, interchangeable during some isotopic exchange there. Isotopic reaction of, I think, even plutonium and uranium would give off some radium and radon in their reactions, respective reaction. Anyway, let's get on here. The element that pops up here is SR, strontium. So we have SR, strontium. And this has an atomic weight of 38, atomic mass of 87.62, and electron configuration now of krypton, Kr, 5s2. That's all I see, krypton 5s2. And this is for strontium, or strontium. Strontium. Okay, we come up to one here that is in the first 20 of the periodic table, and it was usually one of the elements that is relevant in the O-level syllabus. In my time, it was usually the first 20 elements and some other intrinsic popular elements that we use in everyday life. Okay, S. So we have S here, and this is sulfur, atomic number 16, atomic mass of 32, and electrons configuration now of Ne, neon, 3s2, 3p4. That's for sulfur. And you know, they have a lot of allotropes of sulfur. This one, a special note, allotropes, the allotropic form, rhombic sulfur, crystalline sulfur, and all of that jazz. Amorphous sulfur. I want to mix it up here with carbon that has some of these allotropes as well, graphite and carbon and diamond and all of that jazz. Sulfur, but I do believe sulfur has some allotropes as well as isotopes. So the next one on our list of random choices here now is manganese, Mn. And manganese has an atomic mass of 25 and an atomic weight of 54.938, and electrons configuration now of Ar, that is argon, 3d5, 4s2. And if you want the total ground state of magnesium here, will be 1s2, 2s2, 2d6, 3s2, 3p6, 3d5, 4s2, and that will be the notice the 3d5 and the 4s2, which is this, and then this would be the electron configuration of argon, which is the noble gas that pops up in the electronic configuration. Notice as for all elements, they give the noble gas and plus whatsoever electrons are left off after doing the noble gas. So that was for manganese, and manganese was a very popular element that comes up in our O-level syllabus there in chemistry. Can never forget, I had a distinction in Cambridge for my chemistry. Manganese and manganese dioxide there when you're making oxygen with potassium chlorate and manganese dioxide. Well, the manganese is a compound with a dioxide that reacts with oxygen with manganese dioxide, and then you use it as a catalyst, potassium chlorate, to get some oxygen there in the laboratory. So here we have another one, zinc, and this is another popular element as it's outside the 20, but it's very popular in everyday life. On roofs of houses, yeah, that's the most tangible and place you'll see is zinc. Zn, atomic number 30, and atomic weight now of 65.38, and electrons configuration now of AR, 3d10, 5s2. That's a zinc. We move on, and the next one that pops up on my little choice of elements here is indium, In. $49, and this is the number of krypton, 4010, 5s2, 5p1. And so the next one here is another popular element with atomic number way up in the series there. This is either the lanthanide or the actinide series, probably the lanthanoid. Pb for lead. Atomic number 82, atomic mass of 207.2, and an electron configuration now of xenon, Xe, 4f14, 5d10, 6x2, 6p2. So there we have lead, and could make a little note of this one that it's a very well-known element. It's used in making bridges. It's mixed with as an alloy with other metal, iron and lead. Steel, I believe steel is a alloy of iron and some other element there. you have lead, and one of the notes is that in the water, if you have lead, then it can become very poisonous if the volumetric requirement of the lead surpasses the amount, the daily amount that is required to be in the water, or the required volume or mass amount of lead that is supposed to be in water. And then you could have lead poisoning. And we have noted over in history that whole town and city have been poisoned by lead because of the lead. Quantity of lead in water surpasses the amount that is geared for health. So lead 82.207.2 with a little bit of note, and you know that lead is have some isotopes J2, and it turns up in very important nuclear reactions, radioactive reactions there. It turns up in uranium and plutonium disintegration reaction, and also in radon and radium. So we're going to take a break here as we have run out of space this time around. And if we do have time, we'll return with some elements and their atomic mass, atomic weight, and electrons configuration.